Hey folks, welcome back. In this video, I'll talk about scaling. Scaling is one of the most fundamental concepts in system design, and we will see what it means to scale and what are the strategies to scale. And I'll take a practical example. So, imagine you are building these Tech Talks feature, right? And you have stored these Tech Talks on a server and you are just displaying it on a UI. And a server is serving all of the requests for this, and right now the server is using a, let's say, a T2 dot micro instance from AWS, and it has 1 GB RAM and one CPU core, and that's pretty much about it. And we are running a node server on it which is serving all of our requests. Now it is able to handle 1,000 requests per hour, but suddenly our website gets popular and we receive 10,000 or 100,000 requests per hour. And what will happen is the response time will increase because there are a lot of concurrent requests. So from 500 millisecond to 3 second, you might see that big of a jump, and some of the requests might fail because the server is not able to handle those many connections. So what you can do straightforward, so what we can do in this scenario is switch to a better machine, right? We have all of these options available and we can keep upgrading our machine, so we can have more RAM and more CPU and more storage and more and better network hardware depending upon our particular application. If in your application you do a lot of data intensive things, then it might be best to increase RAM, and if you do a lot of compute, then it's better to increase CPU in much more proportion. It also depends, scaling what resources also depends upon the nature of your application. If it is compute intensive, increase CPUs in bigger proportion, and if it is data intensive, increase memory in greater proportion. And we can keep switching to better machines according to our requirements. And that is what is exactly vertical scaling. When you upgrade the resources of your existing machine, or you switch to a better machine in order to serve more traffic, that is exactly vertical scaling. And we also refer to it as scaling up because we are creating bulkier machines. And there are a few problems with this. So one thing is that you can keep upgrading a machine, right? But there will be a certain hardware limit beyond which, even AWS doesn't offer a machine. And what if your requirements grow bigger than that? What if T2.2x large was the biggest machine on AWS? What you will do then? Your requirements are much more than that. And there's also the problem that if this single machine goes down, your whole website will be inaccessible. And there's also another problem that if this machine goes down, your whole website will be inaccessible. And there's also one another problem that if this machine goes down, your whole website will go down. Users will not be able to see your website. And to solve for both of these problems, we have horizontal scaling. And in that, basically, we just have more of these machines. We have multiple of these machines, and we have a separate server that distributes the load on our application servers. So we have multiple of these machines, and each machine is running our application server. And there is a separate server called load balancer, which is just distributing the requests over all of our application servers. And that is how you actually scale infinitely. You can keep adding more machines of the same configuration, and you can distribute all the incoming traffic on those machines through a load balancer. And that is what is horizontal scaling, or also and that is what is horizontal scaling, also known as scaling out, because you're creating a fleet of machines. So you can imagine it as a row of machines, and that is like scaling out. And yes, horizontal scaling solves our problem of, we don't have a and horizontal scaling now solves both of our problems. um, we can keep and now horizontal scaling solves all of our problems. We can keep adding as many machines we require, so to increase our capacity require according to the requirements. And now horizontal scaling solves both of our problems. We can keep adding as many machines we want in order to increase the capacity. And now we are and now we also don't and now we also don't have a single point of failure. Even if one of our application server goes down, we have multiple servers on which the remaining requests can be forwarded to. And that was a brief overview of horizontal scaling and vertical scaling. And in practical terms, what you will do is for vertical scaling, you will keep switching to better AWS instances or whatever other cloud provider that you are using. And if you're running your own bare metal server, then you will add more RAM, you will install more RAM and more CPU. And for horizontal scaling, you will use something like an AWS load balancer, and which you can configure properly to distribute the traffic on your EC2 instances. And you can also use something like Kubernetes. This is a little advanced tool, but once you get used to it, you can manage horizontal and vertical scaling quite easily with it. And this is another tool in your toolkit. So that was a brief overview about horizontal scaling and vertical scaling. Let me know if I missed anything and if you want to see more content. Uh, so that that was a brief overview of horizontal scaling and vertical scaling. And if you like this video, give this video a like and subscribe to the channel. And thank you for watching.